And so here we want to find a polar equation for the ellipse with the given vertices at the polar points of 1, 0 and the point 4 pi, comma pi. And since we're dealing with the polar equation for the ellipse, then the focus will be at the pole or at the point 0, 0. And so let's go ahead and convert these, or let's find the corresponding rectangular points for these polar points. So this is the polar point of 1, r equal to 1, theta equal to 0. And to find the corresponding rectangular point, we use these formulas right here. X is equal to r times cosine of theta, y is equal to r times sine of theta. And so for the point 1, 0, r is 1, theta is 0. So in the place of r, we have 1. In the place of theta, we have 0. 1 times cosine of 0 is 1. And so we get x is 1. And then for the y-coordinate, it'd be r times sine of theta. R is 1, theta is 0. And so we get 1 times sine of 0, which is 0. And so the y coordinate would be 0. And so the polar point of 1 comma 0 is also 1 comma 0 in the rectangular system. And similarly for the point 4 comma pi, the polar point 4 comma pi, the corresponding rectangular point is negative 4, 0. Now let's plot these 2 points. So here's the first vertex, the point 1, 0, and the second vertex, negative 4, 0. And therefore the center of the ellipse has got to be in the middle of the 2 vertices. And so it will be at the point negative 1.5, 0. Once again, the center has to be in the middle of the 2 vertices. And so it would be at the point negative 1, 0. So for this particular problem, the center is at the point negative 1.50. And once again, we're dealing with ellipse in polar equation of an ellipse. Then the focus will be at the pole, which is the point 0, 0. And once again, when we're dealing with the ellipse, then A represents the distance from the center to the vertex. So this is the center to the vertex. And so the distance from here to here is 2.5. And then C is record that C is the distance from the center to the focus. And so this is the center, this is the focus, and so the distance from here to here is 1.5. And eccentricity is defined as C over A. And so 1.5 dividing by 2.5 is reduced to 3 over 5. And so we have an ellipse that's going to be elongated horizontally like this. And since the vertice is here and here, the directrix has to be somewhere over here, which is to the right side of the pole, and the directrix has to be vertical. And so we have a situation where the directrix is to the right of the pole and is vertical, and therefore the equation has to be of this form. R equal to ED divided by 1 plus E cosine of theta. And once again, D represents the distance from the directrix to the pole or to the focus. Now in this problem, we're not given D or the distance from the directrix to the focus, and so we have to find D. we found E, which is the eccentricity, which is 3 over 5. And so the next thing that we need to do is find D. In this problem, we're given that the point 1, 0 is a vertex, which is a point on the ellipse. So this point is on the ellipse. And therefore we can use it to find D. So this is our equation right here. R equal to ED dividing by 1 plus E cosine of theta. E is 3/5. At the point 1, 0, R is 1, theta is 0. So in the place of R, we have 1. In the place of theta, we have 0. And then in the place of E, we have 3/5. And then we can solve this equation for D. So this is what we end up with. R is 1, theta is 0, and then right here, if we multiply everything on the top by 5, if we multiply the top by 5, and then multiply everything on the bottom by 5, 1 times 5 is 5, 3/5 times 5 is 3. And then of course here we get cosine of 0, because theta is 0. And cosine of 0 is 1. So here we have 5 plus 3 times 1, which is 8. And so we end up with R is 1. And then we get 3D for the top, and then 8 for the bottom. And then to solve this equation, multiply the left side and the right side by 8. Then we end up with 8 equal to 3D. And then divide both sides by 3. Then we get D is 8/3. And so the directrix will have a distance from the, of 8/3 from the pole. And so to form the equation, in the place of E, eccentricity, we have 3/5. In the place of D, which is the distance from the focus or the pole to the directrix, which is 8/3. And then once again, E is 3/5. And then 3/5 times 8/3 is 24 over 15. And then to simplify, multiply the top and the bottom by 15. So multiply the top by 15, we get 24. And then multiply everything on the bottom by 15, then we get 15 plus 9 times cosine of theta. And this will be the equation that we're looking for. So here's the directrix, which is the vertical directrix, or the equation will be x equal to 8/3. So the equation for the directrix is x equal to 8/3. And then the graph, the equation for the ellipse is 24 dividing by r equal to 24 dividing by 15 plus 9 cosine of theta.